Transforming basic data structures. Often we want to write these expressions for JSON or Java input and output, and you'll find that it's very similar between the two. The data model can consist of three different types of data: objects, arrays, or simple literals. If we look at the input on the left, which contains first name Max, last name Mule, and then the transformations in the middle column, you can see how they correlate to the different outputs. So if you look inside of this second row here, fname, payload.firstname, you can see how that structure builds out the key fname and puts Max inside of it. As you build out larger structures, you can see the user object holding these details inside, including that simple literal 1, will build out the respective JSON output inside as well. And these structures would look quite similar from a Java perspective, just represented in lists and maps, similar to how JSON has that structure you can see visually on the right here as well. Now, XML outputs will be a little bit different. XML can only have one top-level value, and that must match an object with one property. Otherwise, you're going to throw an exception, as we saw with our stream exception. So, if we switch up the expression you see in the top here with just fname and lname, you can drop down to the bottom where we wrap those in effectively a user object. That way the top level user tags can wrap, as you can see on the output on the right, the fname and the lname inside of the XML output. So structurally it'll look a little bit different, and there are some other syntactical differences regards to attributes and the elements and things like that that we'll learn about soon. Now, again, going back to that attribute conversation, say we want to not just construct this user, but we also want to add in fname as an attribute and lname as an attribute. Well, syntactically, we can do this with the @ sign in the parentheses, wherein on the user tag we can specify the fname and the lname specifier, and then inside of that still specify lname in this example, which will create a structure such that user is in with fname and lname as attributes, and then also the standard lname elements inside of the user tags as well. So some more examples around writing expressions for XML input. By default, only XML elements and not attributes are created as JSON fields or Java object properties. And we need to use the @ to reference these attributes. So this is, again, going from the input this time of XML to an output of JSON or Java. So just going from payload, no big deal. We'll wrap the user in the last name, just respectively as it is in the XML. If we call just payload.user instead here in the second row, we'll effectively be creating the last name and the value, omitting that user object effectively or user tag. And then inside of here, if we want to grab onto that first name and use it in our JSON output, since JSON and Java don't necessarily have this attribute convention, we'll have to call payload.user, and using the @ sign once again, tell it I want the user attribute first name, and then underneath that, I want the user element last name, and that will respectively create the JSON structure you see here on the right. Now let's get into some of these transformations. In walkthrough 10.2, we'll transform basic Java, JSON, and XML data structures. We'll write expressions to transform the JSON payload to various Java structures, create a second transformation to store a transformation output in a flow variable, and write expressions to transform the JSON payload to various XML structures. Let's get started. Back in Anypoint Studio, in our implementation XML, let's go back to the message flow tab and select our transform message processor. Here we're going to begin typing in the dataweave expressions. Now after payload, let's put a period in place to get some autocomplete going around what we can put in. From the pop-up menu, let's choose price as our first option. Now that we've got price in place, if we make sure our preview pane is open, we can see how we're beginning to construct this Java element where we have the root integer of 199 in payload price. Now let's put a key in front of it, so we'll do data : price, and you can see how it's now assigned the key data, it's switched to a map, and the value is 199. Let's now drill this back down to just say payload, so that it creates the whole structure once again. Now we're going to make one more altercation to the expression, and that is to change it to data, but this time with an object inside of data. So we'll use two curly braces to show that. We'll then open up those curly braces and put in a key for hub in which we can specify MUA. So now we can see this data structure coming in place where we've got the root linked hash map, a data element, and inside of that data element, the hub specifier as well. We'll now add another object inside of here that we'll call code, and code will have the value of payload dot, and let's make sure we have a comma at the end of hub, otherwise we'll break our structure here, and we'll do to airport code, do another comma, and drop down and specify the airline, where we'll say payload dot airline. So you can see, even without the graphical phase, it is still quite easy to start creating this structure just by typing out these different values. All right, now that we've got this basic Java structure in place, let's try adding a new target in the top. The target we're going to add is going to be called a variable, and the variable name is going to be XML, in which case we'll keep it as inline and hit OK. All right. So now we have this flow_var XML. If we drop this down, you can see we still have access to our payload transformation and the ability to toggle between our flow_var and our payload. Now, for the flow_var XML transformation, let's also make sure the preview button is open. And let's set the expression inside of here to payload and the output to XML. Now, as we'd run into before, we get that same issue. So let's change the expression so that it has a key at the beginning of data and hit colon. Now we can see it's able to satisfy the preview all right because it knows to wrap the body inside of here in the data tags. Now let's drop this down again and go back to the payload option. And let's copy this expression that we had just written inside of here, data, hub, code, and airline. We'll switch back to the XML structure, and let's go ahead and paste that in. Now, obviously, this works as well. As long as it knows to wrap everything in data, it can put these data tags in and then have the tags for hub, code, and airline, respectively. Now, let's try to change it up just a little bit more. Inside of data, we'll keep MUA in the hub just as is. And let's say that we want to wrap these in a tag of flight. To do that, we'll go underneath hub and we will say flight, colon, and open up the beginning of a new object. We'll then end the object down here. And for the clarity of the object, let's go ahead and indent in as well. And now you can see hub is an outer element of data, or a primary element of data, so is flight, and then inside of the flight is the sub-element code and airline. So we can see how easy it is to manipulate this structure. Now let's pretend the airline United should actually be an attribute inside of the flight tag. Well, if we take out the airline payload.airline from here, make sure we remove that extra comma. At the flight level, we can now add in the @ sign in the parentheses. And inside of here, we can once again specify the airline, in which the value of the airline is payload.airline. And I'll move this over just a bit so it's easier to read. So flight and airline, payload, airline, and you can see how it puts that right in the attribute field rather than its own tag. Now, let's go ahead and save up the application with the changes we've made. Let's run the application in debug mode. If you were already running it, it may have restarted. In my case, I'm going to stop the application and run it in debug mode one more time. Now that the application is deployed successfully, we'll go back to Postman and make that same request we were doing before. We'll send the request in and head back to Anypoint Studio. Now, if you step onto the logger after we've made these changes, we can now see that the payload inside of here is once again that Java object with our different values as you scroll through. If we go to variables now, we can see that we've actually stored the XML data inside of a flow variable. So just like a payload, we can store JSON, Java, XML bodies inside of these variables, all inside of the same transformation script. Now, let's stop the project here and let's talk a little bit more about complex transformations with different data structures and arrays.